Hey science enthusiasts! Welcome back to Odd Bytes Brief, where we turn up the heat on cool scientific mysteries. Today, we're going to challenge a belief that's as common as the cold glass of water in your hand. Picture this. You have two identical cups of water, one hot, the other cold. Now, pop quiz. Which one do you think would freeze first? Most of us would bet our last dollar on the cold water, right? It's only logical. After all, it's closer to freezing point. But what if I told you that sometimes in the strange and wondrous world of science, hot water can actually freeze faster than cold water? Yes, you heard that right. It's a phenomenon that's been baffling scientists for centuries, known as the Mpemba effect. Well, hold on to your ice cubes because that's not always the case. Enter the Mpemba effect, where hot water can freeze faster than cold water. Yes, you heard that right. It's like a magic show, but the magician is none other than our everyday H2O. This intriguing phenomenon is named after Erasto Mpemba, a Tanzanian student who stumbled upon it during a school experiment. While trying to freeze a hot mixture for his ice cream faster, he noticed that the hot mixture turned into ice quicker than the cold one. Imagine his surprise. This peculiar observation caught the attention of the scientific community, and thus, the Mpemba effect was born. But don't let its simplicity fool you. It's a conundrum that has left scientists scratching their heads for decades, challenging the boundaries of our understanding of the physical world. But why does it happen? It's a head-scratcher, all right? Now dive into the theories. Is it evaporation, supercooling, or perhaps something even cooler? Let's start with evaporation. Some scientists believe that when hot water is cooled, it loses mass to evaporation. With less mass, the water cools more rapidly, and thus freezes faster. It's like a weight loss program for water. But not all scientists are sold on this theory. Another theory on the table is supercooling. This is when a liquid is cooled below its freezing point but does not solidify. It's like the water is holding its breath, waiting for the perfect moment to freeze. Some scientists argue that cold water supercools more than hot water, causing hot water to freeze faster. But this theory also has its skeptics. Then comes the convection theory. In this scenario, when hot water is cooled, it undergoes convection, where warmer water rises to the top and cooler water sinks to the bottom. This process can cause a faster rate of cooling, leading to quicker freezing. Yet, like the others, this theory has its doubters. Scientists have also explored the role of dissolved gases. You see, hot water tends to contain less dissolved gases than cold water. Some researchers argue that these gases could affect the freezing point of water, with hot water freezing faster due to lower gas content. But again, the jury is still out. To test these theories, scientists have conducted various experiments, changing water temperatures, container shapes, and freezer conditions. From using high-tech thermometers to measure water temperature to employing advanced techniques to observe the freezing process, these experiments have been as varied as the theories themselves. Some say it's about hot water losing heat faster, while others argue that dissolved gases might play a role. It's like a scientific showdown of frozen proportions. At the end of the day, the Mpemba effect continues to be a frosty scientific mystery. And that's what makes it so incredibly cool. And there you have it, folks, the fascinating world of the Mpemba effect. We've journeyed together through the icy enigma of water's freezing paradox. We've challenged common beliefs, introduced a scientific mystery that has puzzled minds for centuries, and even dipped our toes into the theories and experiments that scientists have conducted in their quest to solve this frosty conundrum. Yet, the Mpemba effect remains a cool and captivating mystery. Whether evaporation, supercooling, or dissolved gases hold the answer, the scientific showdown continues. So, why not join the discussion? Perhaps you have a theory of your own or an experiment to share. But remember, science is not just about finding answers. It's about asking the right questions and never losing that spark of curiosity. So until next time, stay frosty and keep the curiosity flowing. Signing off from Odd Bytes Brief and Science High Fives to all the frosty minds out there.